That's wonderful. Actually, that complements to the next question I had in my mind. I was thinking about that. It's like, and then you develop this model, and then you use this data. So, in terms of data that you have used in your paper, and you said like already real data that you've collected for that. And in order to show the efficacy of your method, do you have to use any simulated data, or was it like all real data that you've used? If so, what are the challenges you had in terms of generating and creating these kinds of data sets that you have used in this paper?
Yeah, it's an excellent question, and I appreciate this question. It's obviously for sentiment analysis, we cannot simulate data, so it's all real data, but it's very challenging to collect data because if you can think about how sentiment is expressed differently in different content or in different contexts. So initially, we collected data that was published in by different users as response to news articles that were related to the corona. We followed some papers that saying that this is the most emotional period that people express emotions. It was very important for us, but after we collected the data, and again, we collected the balanced data, we realized that people might express the emotions differently if the context differs. So in the second round, we collected just general user-generated content from the same website because they kind of represent the sectors in Israel, but they were posted in response to random news articles. And we did not retrain a model. We rather use our initial model and see whether it's robust to additional data sets, and we concluded it is. It's not, obviously it's not the same performance because emotions is very hard to detect in the general case, but the performance actually is actually really good for additional data sets.
That's wonderful.
I do want to, if you don't mind, I want to add a limitation. Obviously, if we try to use a model for non-user generated content, but for other contexts like literature, the performance might look a little different.
Sure, yeah, I mean, it depends on the data, but I think it's good to see that the robustness of the model, even on the general data sets that you fixed in that too.